4-bore alumina tube, a high-purity aluminum oxide ceramic with 4 parallel internal channels running through a single outer body. Each bore is separated by a dense alumina wall, providing 4 isolated pathways for thermocouple wires, sensor leads, or gas lines within one compact tube. Available in purity grades up to 99.7% alumina, supporting continuous operation at 1,650 degrees Celsius. Three properties define why this tube works for multi-channel applications. First, bore wall thickness of at least 1.2 millimeters between adjacent channels, delivering electrical resistivity exceeding 10 to the 6th OH/m centimeters between bores, enough to prevent signals crosstalk even at 1,200 degrees Celsius. Second, thermal shock resistance exceeding 200 degrees Celsius differential, allowing the tube to survive rapid furnace cycling without cracking. And third, dimensional accuracy within plus or minus 0.05 millimeters, ensuring repeatable sensor alignment across production batches. The 4-bore design consolidates what would normally require 4 separate single-bore tubes into a single sheath. In a multi-zone tube furnace, each bore carries one thermocouple wire to an independent temperature measurement point. This reduces furnace wall port usage by 60%. Instead of 4 separate penetrations. One penetration handles all 4 sensors. Uniform wall thickness and bore spacing ensure consistent thermal contact across all 4 channels, limiting temperature deviation between adjacent thermocouple readings to less than 3 degrees Celsius at 1,200 degrees Celsius, in a documented case at a German materials laboratory, switching from 4 single-bore tubes to 1 4-bore tube in a 4-zone furnace. Cut installation time by 50% and improved thermal uniformity by 12 degrees across zones, while reducing sensor failure rate by 30% over 6 months of continuous operation. Each bore is electrically isolated from its neighbors by a dense alumina wall with resistivity exceeding 10 to the 6th OH/m centimeters. This wall thickness of at least 1.2 millimeters acts as a physical barrier against electromagnetic interference between adjacent signal lines. Critical and high-sensitivity temperature control loops where even millivolt-level crosstalk can shift readings. The alumina dielectric properties remain stable even under reducing and corrosive gas atmospheres, including hydrogen. In a South Korean RF plasma generator project, replacing 3 separate single-channel ceramic insulators with one 3-bore alumina tube eliminated arcover events at 12 kilovolts. The consolidation reduced internal wiring volume by 45% and improved system uptime by 22% over a 4-month production cycle, while enabling safer integration of high-frequency, signal, and power lines within a single ceramic housing. Consolidating 4 channels into one tube body directly simplifies furnace wall integration. The number of wall penetrations drops from 4 to 1, reducing feed-throw complexity by 70%. Fewer penetrations mean less thermal leakage through the furnace wall and lower mechanical stress at mounting points. During installation, the tube should be secured with ceramic holders or clamps, avoiding direct mechanical force on the tube ends, and heated at a ramp rate of no more than 5 degrees Celsius per minute to prevent thermal shock at the bore walls.